the videos up. I have the smart boards up, but not the videos. Okay, first things, guys. The quiz for today, we don't have enough time to take it today. It's 4 pages, but it's spread out. But that will take tomorrow. Okay, Alex? Quiz is tomorrow. Tomorrow we're going to do trapezoidal rule, but I don't think I need to teach it because you already know it. And you can just work on those problems. The assignment on the assignment sheet is wrong. Take the assignment that's on this gold sheet. There's only 4 problems to do. And you'll be very happy it's wrong because what you have to do on the problem I assigned is really hard. But that's beyond this course. So that's okay. We're not going to do that. But we're going to do this. Now we're going to do partial fractions. We've done the 1 over x minus 1. I can do it again if you want, or we can just jump into the hard problem. You remember this one? Okay. Yes. I want to integrate 1 over x times x minus 1. Okay, guys? Yes. I have plenty. Anybody need one? This, because I can't integrate that. That is the same as 1 over x squared minus x. And you can try to use substitution, and it's not going to work. So we won't do that. So I'm going to move this guy down. And let's just go ahead and do what I call the easy problem. The problems I've assigned are not easy. So what we're going to do is try to figure out, okay, guys, Nick, phones put away, please. We're going to try to figure out what we added together. I know that one denominator was x, and the other denominator was x minus 1. And if you had common denominators, you could do all that work, and you could add these up and come up with that. Well, I don't know what the number is here. By the way, this only works when the denominator has linear factors. In other words, you can factor it so that these two are just linear equations, or expressions. Excuse me, that was wrong. Okay, now I could get common denominators, but easier than that is to clear out the fractions. So I'm going to multiply everything by x times x minus 1. Because it's not an inequality, I can do that. And this will cancel here, and I'm left with 1 equals, and let's see, I'm left with a times x minus 1 plus b times x. And you can put any number you would like in there. That is a collapsing sum. You know it is integrable and it converges because of the piece series, remember? Okay, so, but we're going to try to integrate this, is what we're going to try to do. So that's not going to work either. Try. Whoops. Okay, what number would you like to put in for x? I can put any number I want in, but if I put in x equal to 0, I get 1 equals a times negative 1 plus b times 0. So a equals negative 1. Okay, if x is equal to 1, then I get 1 equals a, 1 minus 1. It chose it that way, so that goes away, plus b times 1. You can put any numbers you want, but then you get a system of equations, and that's harder to solve. This is easy to solve. This is a trick, and it's not written up in your book. To be honest with you, they don't do it this way. So there we go. So I know what I added. So I'm going to integrate a, which was what? Negative 1 over x dx, because I can distribute my integral over the sum, plus the integral of b, which is 1 over x minus 1 dx. And now I can integrate that and make sure that you are able to match your answers. This is a negative what? What's the integral of 1 over x? Oh, we forgot? Natural log of the absolute value of x. Plus, what's this one going to give me? Natural log of absolute value of x minus 1 plus what always must we add? Plus c. Now, it's not critical now, but it's going to be critical. And the CAS calculator does not add the c in. So you have to be aware of that fault of the calculator. Well, this is really this. It's the natural log of the absolute value of x minus 1 minus the natural log of the absolute value of x plus c. That's right. So we can write it this way. Natural log of x minus 1, absolute value of it, over the absolute value of x. And there's a property with absolute values that allows me to rewrite that as the log of the absolute value of x minus 1 over x. Okay? So do you remember that process? Are you now remembering the process a little bit? Well, you can see if I go to the next slide, that's what's on the exam. That's why you have only 4 problems to do, but it's good problems to do. So let's do this hard one here. And it's not going to be as bad as you think. And you're going to say, well, what are you going to do with? I'm saying, let's just do it the same way we just did it. Exactly the same way. Now, I'm hoping I get linear factors out of that first example. I believe I can. Okay, let me slide it a little bit. Whoops. Okay, so I really want to know, what did I add together? So I have 5x minus 4. Have you factored that denominator yet? If it doesn't factor, I'm in trouble. The reason why u substitution won't work is because if I let u equal 2x squared plus x minus 1, then du is equal to 2x plus 1 dx. The 2 isn't the problem. It's that I have 5x minus 4. If I had 2x, oh, sorry. If I had, well, it's still not going to work. If I had a 4x minus 4 out of that, then I could do a u substitution. But this doesn't match. Minus 4, I can't fix it by multiplying by a number. So let's factor that. Did you guys do it? X, 1 and 1, I'll put my signs in. Plus and minus, is that right now? Yep. How do you know? Multiply it back out. Yeah, multiply it out. So I'm going to have a over 1 factor plus b over the other factor. Now, what do we do next? We multiplied by the least common denominator, which is this 2x minus 1, x plus 1. And this is 2x minus 1, x plus 1. 2x minus 1, x plus 1. That goes away. And you're saying, well, 5x minus 4 does not go away. No, it doesn't. So it's a times 2, x plus 1. Right? 2x minus 1 will go, so this is x plus 1. The x plus 1s will cancel, and this is plus b times 2x minus 1. Forget the left side. I don't care what it is, really. I just care what I want to put into the right side. How am I going to get 0 for one of those factors? X is equal to negative 1. Now I'm going to put it in here. So that's negative 5 minus 4 equals a negative 1 plus 1. Because that's the only thing I can think of to do. I'm just going to do what I did. Plus b times 2 times negative 1 minus 1. And simplify that. I'm going to get negative 9. That's 0. Negative 1, because what happens to this term right here? That's 0. And this is b times a negative 3. Well, that's not so bad. B is 3. Okay, Alex? No, you don't. Okay. Good. What's the next x value we're going to put in? 1/2. X is equal to 1/2. Sorry, we have fractions. So it's 5 times a half minus 4 equals a 1/2 plus 1, 1/2. I wrote it 1/5 for some reason. But I substituted it in right, at least. There. And what happens to the b's? That's 0. I can use anything I want, though, and get a system. It's not fun. Okay, so I get 5/2 minus 4 equals 3/2 times a. You want to deal with the fractions or get rid of them? Really? I'd rather get rid of them. Multiply by 2, and then I don't have a problem. And I'm pretty good with fractions, and even I want to get rid of them. So multiply everything by 2. So I'm going to get, that's right, 10 minus 8, which is easy to do, equals 3a. So 2 equals, well, the 2's cancel. 5, yeah, let's try that again. Okay, that cancels. It's 5 minus 8 equals 3a. Oh, that's much nicer. Well, they might be fractions. On the other one on the back page, it is fractions. 3a, and so a equals -1. Then we substitute it back in here. So I'm going to have the integral of a was 1/2. No, a was 1, right? -1. -1 over 2x minus 1. It doesn't hurt us to integrate this. And b was positive 3, wasn't it? Positive 3 plus the integral of 3 over x plus 1 dx. Let's look at that. Okay, which one I grabbed. Doesn't matter. So let's go ahead and integrate that because it won't hurt us to know how to do that. I just put a back in for a. Where's a? A was right here. So a was, pardon? I know, it's very hard. And then I substitute b in. Yes, I keep pushing them back and they keep coming forward. So a was -1 and b was 3. Then I'll integrate each piece of that. No, these are equal. This equals this stuff. Okay, how are you going to integrate this one? The first one might be a little tricky. Let's do a u substitution. U equals 2x minus 1. If you don't see it, so what's du? 2 dx. So I'm going to end up with a -1. I'll put that in front. And then that's 1 over u. And then dx is 1/2. So I'm going to put a du here and divide by 2. That's right. Just ahead of me, which is good. Plus, pull the 3 out. I don't need a u substitution here, do I? Can you just do that one? And this is probably in the book, I'm going to guess. Okay, so what am I going to get? -1/2. It never hurts you to put the absolute value sign in. It hurts if you don't put it in when you need it. But if you don't need it and you put it in, no big deal. Plus 3 natural log of x plus 1 plus c. What was u? It was 2x plus 1, wasn't it? I got to go back and look. Let's go look. I did it right here, 2x minus 1. Now, it used to be, with copy errors, that if it was obvious you copied it wrong, like I made a +1 there, it's pretty obvious. They didn't take it off, but now they are. So you're going to lose a point if you do a copy error. And that's good enough. Trying to combine them is going to be trickier. You'd have to put this -1/2 up here and the 3 up there, and I don't know that they ask you to do that. So we don't care. Okay, the next problem on the back is an AP question. So try that one. What do we know? Is this one okay? We're not going to do take derivatives. Notice the assignment is right here. Change the one that's on the assignment sheet. I should change the assignment sheet. You will be thankful. Do I need to set this up with you? Or do you want to try it? Well, you can throw out the ones that are obviously not right, which would be D and E. You know you're going to have logs, right? Which one it is, I'm not quite sure by just looking at it. My guess is going to be A. I don't know for sure. The reason why I say that is when I do my U substitution on here, I'm going to get a 2dx, so I'll have a 1/2. But they may cancel out someplace else. I'm just looking at it. I haven't done the problem, so I don't know. So you guys try it. Anybody want to come up and do it? This is a partial fractions. You can try to do a U substitution, you won't get it to work. Nope. You have to recognize it. Yes. Because you can try a U substitution and it won't work. No, it's always trial and error. But I see the collapsing sum. It looks like 1 over x times x minus 1. Kind of.
Why do we have to do collapsing?
Because it's a method to integrate. And the collapsing sum, if you were ever interested, is how you prove the fundamental theorem of calculus.
Let's save that for another day.
Oh yeah, we don't have time. I have the schedule worked out right to spring break. We have 1 day of wiggle room, that's it. And if we finish Tuesday before spring break, then Wednesday we'll work on AP problems. After break, we'll come back and fly through chapter 7. So only one new thing there. You're going to have a lot of new stuff before spring break. We're going to do the polars. Polars. Yeah. You'll get the pretty pictures. It's another coordinate system. So, Nick, are you going to try this? Okay. Shouldn't need a calculator. So we'll spend the 2 weeks after break finishing up chapter 7, maybe a week and a half, and then we'll start reviewing. The week right before the exam, we will be doing the Taylor stuff. Because what do we get? We get the integral. What's A? What does A end up being? 3? And B is 2. This one's okay. The second one is 2 times the log of the absolute value of x plus 2. But this one is 3, and if you take the log of 2x minus 3 and you take the derivative of it, the problem is you have a 2 there. So I have to divide by the 2. If you let u, another way to do it is if you let u equal 2x minus 3, then du is equal to 2 dx. So I use substitutions. I like them. But you should be able to look at them and see. No, that's not the right pink one. Okay. The question was, how do you do the last problem on yesterday's worksheet? What is that? It's the integral of what? Help me out with that one. It's 5 to the x. Well, what else is there? Because I can integrate that. Girls, you had the question on this one. I don't have my worksheet handy. With an x here? Okay. If I didn't have the x, life would be good. Because what is the integral of 5 to the x dx? Do you remember that one? John, do you remember this one? It's 5 to the x. The derivative is times the natural log of 5, so the antiderivative is divided by the natural log of 5. Okay. What would you like u to be? Okay, Ellen, did you get this one? X. Then dv is equal to 5 to the x dx. Well, because you are taking account of parts, you got to be careful that you include all the parts. Then what's du? Times dx. Another reason I don't want this to be dv is then I get x squared over 2, and things start looking worse. Right, if you do the wrong way, You'll say, hey, it got worse. I must have chosen them wrong. You guys want everything to always be easy. Unfortunately, it doesn't work that way. Okay, so it's u times v minus v du. So it's going to be u times v. So it's going to be x times 5 to the x over the natural log of 5. Let's see. Minus the integral of this, 5 to the x over the natural log of 5 times du just ends up being dx. Had that been x squared, guess what? We'd have to do it twice. If you go the wrong way, you'll find this keeps getting worse and worse. But remember my hints, because if you can remember that, then that's what you do. You always let u be something that will change form or go away, not stay similar. So it's 1 over the natural log of 5 times x. It's the product rule. You multiply these two guys together. Minus 1 over the natural log of 5, the integral of 5 to the x dx. I just don't want you to get confused about these log of 5s. And this is 5 to the x over the log of 5. And you know, if it's right, by taking the derivative. Are there other questions you have for me? I didn't give you a big assignment, but it's all new for you. Don't assume you know how to do it unless you practice it and feel confident with it. Because when you get on the exam, it's going to be stressful, as you know. I'm prepared to do other questions. Do you want to see that? Yeah, it's been corrected for a while. No questions, going to stop my video.